So we're going to talk about survey problems. On your handout, I've given you to remind you what Venn diagrams look like and what the regions are in a 2 and a 3 diagram, and this kind of gives you an overview of the intersections and that. And you've got some general procedures for constructing Venn diagrams. We're going to, I'll let you look at that because we're going to talk about those things as we go. So first thing we're going to do is name the regions of a 3-set Venn diagram. So this is example 1. And we are looking at naming the region. So the first region I'm looking at is, I want you to name, so this would be part A. If we're looking at R6 plus R7. So looking on our diagram, let me see if I can zoom in just a little bit here. Let's see what happened overlay there. Okay, so R6 is this part right here, and R7 is this one here. So if we're looking at that, let me kind of curve around that, this area right here, that is the area that intersects between B and C. So this would be the B intersect C region. If we're looking at part B and we want to set name, we want it for R2. So R2, well, how are we going to name that one? Because R2 is just this area here. You can't include any of those. So we would take set A, and we need to subtract out the union of B and C, because those are in B and C. So if we take out all of B and all of C, that would leave us with set A. So it would be minus B union with C. Now you could also do this another way. If we took the complement of B, which would be everything outside that, and we intersect that, and we take the complement of C. There's another way. I would always go this way, but they say that you could take A and intersect it with B complement and C complement. Remember, B complement is everything outside of B. C complement would be everything outside of C. So it would be this area, which would be this and that. And then we'd just take the intersection of those. So the intersection of C complement, B complement, and set A. The only thing that all of those would have in common would be that R2. But I think this one's a little bit easier to see. All right, let's look at part C. What regions, if we're just looking at A minus B, tell me the regions. So if we want to find the regions. So if we're taking A and we want to subtract out B, what does that leave us? Well, that leaves us with R2 and R5. So this would be R2 plus R5. So that's just being aware of what the regions are and what it takes to kind of make those happen. Alrighty, so let's go on to example 2. So example 2 is more of a survey. That was to kind of get you aware of your regions and what's happening with those. So for example 2, we are looking at a survey of TV viewer preferences. So a television network conducted a market survey to determine the evening viewing preferences of people in the age to 18 to 25 age bracket. The following information was obtained. So we have A through H. From this information, determine how many people do not want to see reality shows and how many prefer to watch TV on the weekend. We're going to use W for those who want to watch on weekdays, E for early programming, and R for reality shows. So let's go draw this out. We're going to draw it out on a Venn diagram. And we'll need 3 circles. And we need to overlap them. And your circles don't have to be perfect, as you can see mine are not. So we've got W, E, and R. So weekend or weekday, early programming, and reality shows. So now we're going to go down our list, A through E. So 3 prefer a reality show early on the weekdays. So they like the reality, the early, and on the weekdays. So the intersection of those is going to be in the middle. So this will be a 3. Now, B says 14 want to watch early on the weekdays. So early on the weekdays, that would be the intersection right there. It says it's a total of 14. So 14 minus 3 would be 11. 21 want to see reality shows early. So reality shows and early overlap here, and it says 21. 21 minus 3 will get us 18 here. Next part, 8 want reality shows on weekdays. So 8 minus 3 would leave us with 5. 31 want to watch TV on the weekdays. So on the weekdays, we have this number here. This is our W, and it's 31. So we have to take 31 minus the 11, the 3, and the 5. So let me show you a little bit of math. So for part B, let's kind of step back for just a second so you make sure you understand what I'm doing here. So part A, it's just 3. For part B, I took 14 minus 3 equaled 11. For part C, I had 21 minus 3 got us the 18. For part D, we had 8 minus 3, which equaled 5. Now we are on part E, and part E is all the weekday, with a total of 31 minus the 11 plus the 3 plus the 5. So we have to take out all of those, and that will leave us with 12. So that means up here we're going to have 12. All right, let's go look at part F. Part F says that 36 want to watch TV early. Well, early lands all the way up here, and it said 36. So we have to take 36 and subtract out 11, 3, and 18. So 18 plus 3 plus 11, and that will leave us with 4. So that means there's 4 more that end up right here. And then the next one, for part G, it says 40 want to see reality shows. So for part G, we have 40 minus our 18, 3, and 5. And that will leave us with a total of 14. So that means there are 14 that just want to watch reality shows. And then the final statement says 13 prefer late weekend shows that are not reality shows. Well, that's going to go out here in our universal set. So the 13 will be out in our universal. So you just have to do some subtracting to figure out. Now, the question said, from the information, determine how many people do not want to see reality shows and how many prefer to watch TV on the weekend. So how many want to do not want to see reality shows? So how many, oops, do not want to, watch, I'm just going to create it down, reality shows. So if I'm looking at the reality shows, not wanting reality shows, I've got to add up who don't want them. So that means I'm going to cover up my R. That leaves me with 4, 11, 12, and 13. Don't forget the ones out here because I don't want reality shows either. So all of this circle, gone. So that'll be 12 plus 11 plus 4 plus the 13 on the outside, and that'll add up to be 40. The next question asked, how many prefer to watch TV on the weekend? So how many prefer to watch TV on the weekend? Well, that means not the weekday, right? So we're going to cover up the weekday part, and we will be adding up the 13, the 18, the 14, and the 4. And it doesn't matter the number you put them in, as long as you gather all the numbers that are not weekday and are the weekend. And when we total that up, we will get a total of 49. So we can say that 49 want to watch the TV on the weekend. Okay, so our next problem is example 3. We're looking at surveying media users. So, a media company that produces Pilates videos surveyed its customers to determine whether they would prefer to purchase the videos by buying an access code to allow them to download from a website, purchase hard copies on a DVD, or access the videos via a podcast. The company has extracted the following table of information from its customer base. So here is our information that they've done. We've got under 41. Let's see if we can get a little closer. So we've got 41 that are young, 41 to 55 that are middle-aged, and over 55 are senior. And then we've got our totals right here. So find the number of elements in M union with D. So we're looking at finding M union with D. M is middle-aged, so this is going to be example 3. So M union with D. And we're looking at the middle age union with the DVD. So when we're, because that's our first thing, the number of elements in M union with D. Now, we know that that's where they overlap, but we want to find the union. That would be the intersection, right? So the union is going to be all of these and all of these, but we're going to have to take out the intersection where they actually overlap. So looking at the number of that is going to be equal to the number of the middle-aged plus the number of the DVDs minus the number of the intersection, because it will get counted twice. If we don't subtract that out, if we took both column and row, it would subtract that out. So the number of middle-aged is, if we total this all up, here's our total down here, that's 86, plus the number of DVD totals is 22, minus the intersection that we talked about is 8, and that will leave us with 100. So that's the number of elements in the middle age with DVDs. Now we want to find the number of elements in A complement. This is part A, here's part B. I'm going to come up just a little bit so you can see. So part B, we want to find the number of A complement. Now remember, A complement means it's everything outside of A. So we want to find the number of elements in A complement, but we don't want to buy the access code. So that's what A is. That means that's what we're looking for. They don't want to buy the access code, so how are we going to find that? Well, if they don't want to buy A, then they must be doing either the podcast or the DVD. So this would be equal to P plus D, which would be 63 plus 22, and that would be a total of 85. All right, now let's use a Venn diagram to find out the numbers that we're looking for here. This is our last example. This will be example 4. So for example 4, we're using the Venn diagram to solve the following. So here's our Venn diagram, and we just need to use it to figure out what's going on. So if we're looking for the number in A, that's the number in A itself, we have to, this is all of set A, so we just got to take out that little part right there. So we're going to have to add 7, 11, 5, and 2. So 7 plus 11 plus 5 plus 2, and that'll get us 25. If this is part A, for part B, we want to find the number of C complement. So the number of C complement, well, that's going to be everything outside of C. So that'll be 7 plus 2 plus 3, which will get us 12. Part C is the number of A minus B. So if we look at A minus B, that means we're taking this out. So we'll have 7 plus 11, which is 18. Part D is N, the number of B union with C. So being union with B union with C would be 2, 5, 11, and 13. 2 plus 5 plus 11 plus 13, which will get us, make sure that's right, 2 plus, yep, is 31. Part E is N, the number of A union with C. So all of A union with C. So A, oops, yes, A, that should be intersection. A intersected with C, I need to change that. So this should be an intersection. Intersected would be, that's where they overlap, would be 11 and 5. 11 and 5 would get us 16. And our last one would be N, the number of B minus A. So if we take B and subtract out A, that's actually going to be our empty set, which means there is nothing left. If we take B and subtract out A, which is the B is part of A, we will have nothing.